last half of the first section in chapter 6, oh my word, we're going to do more factoring. We factored some in the last section. Today we're going to factor out numbers that have negatives, and then we're also going to factor by grouping. All right, so let's just jump right into it. What I'd like to do is I'd like to start with a little bit of a review of what we did when we factored binomials like this. So remember, we had to find a greatest common factor. And so we found the greatest common factor between the constants and then with the variables. And so with these, we look to see if you can see it quickly and immediately. That's great. If not, remember, you can do your factor tree. 30 is 3 times 10, and 10 is 2 times 5, and 45 is 5 times 9, and 9 is 3 times 3. And then you can look to see, oh, they have a 5 in common, and they have a 3 in common. So 3 times 5 is 15. All right? So 15 is our GCF between our constants. And then an XY and an X have an X in common. So 15X comes outside of the parentheses. And then what's left inside the parentheses is what's left from these two terms after we divide out the 15X. So when we take a 15 out of 30, 30 divided by 15, it leaves you with 2. And if you take the X out of the XY, what's left is the Y. And when you take the 15 out of 45, is going to be a 3. So minus 3, because don't lose this negative sign. And then the X, you don't have anything left if you've taken the X out. So 15X times 2Y minus 3 gives you 30XY minus 45X. Now, with this, we like to keep the number inside the parentheses, we like to keep that first term positive. So if we have a trinomial in this case where the first number is negative, we want to keep that first term positive. So what we want to do is we want to take out a negative number instead of a positive number at the front. Now be careful when you do that, because if you take a negative out of this term, you're going to have to take a negative out of every term involved. So that's going to be the part where you're going to mess up. Make sure that you take that negative out of the whole string of numbers. Okay? Let me show you what I mean. Between 10 and 15 and 25, hopefully you can see immediately without doing the trees that 5 is in common with each of these. This is 5 times 2, 5 times 3, and 5 times 5. All right, so we're going to take 5 out of each of these constants, but we want to keep this first term positive. So we want to take a negative 5 out of there, all right? So that what's left is a positive 2, all right? Negative 5 times a positive 2 gives you the negative 10. So far, so good? All right. So now when you do that, you need to make sure that you take, so what's in common is not just the negative 5. Let's look, so that's the constants. Let's look at our variables. We've got an x to the third, x squared, and an x. So that smallest term is what's in common. The smallest variable is what's in common to all of them, because there's an x in each one. So we pull out an x. When we pull out one x from here, we still have x squared left. So 2x squared times negative 5x, if we multiply these two terms together, we're going to end up with the negative 10x cubed. All right? Now, for the next term, we've also pulled out a negative 5. So this was negative. If we pull out a negative 5, it now becomes positive. Okay? So if you pull out a negative, all of your signs inside the parentheses are going to be opposite of what they started out as. So now this is going to be a positive 3, and then the x times one more x gives you x squared. So now when you go backwards to check it, negative 5 times a positive 3 gives you the negative 15, and x times x gives you x squared. So far, so good? All right. So now to get positive 25, you're going to have 5 times 5 is 25. And your sign in between here, because it was positive, and we want the opposite of that, it's going to be a negative 5. And then if you check it in your head, negative 5 times negative 5, negative times a negative is a positive 25. And then the x, we're pulling out the x, so all we have left is just the 5. Okay? So then you can always check that. You can always check it to say, I don't know if I did this right. go backwards and check it. So multiply, just like you did before, multiply each part by each part. Negative 5 times 2 is negative 10, and x times x squared is x cubed. And then multiply negative 5x times 3x. Negative times a positive is a negative. 5 times 3 is 15. X times x is x squared. And then negative 5x times negative 5. Negative times a negative is a positive. 5 times 5 is 25. And x times nothing is going to be still an x. So x times 1. So then we look to see, yes, our check matches our original, so we are correct. All right, that's how you can always check to see if you've factored correctly. All right, you ready to move on to the next thing? This is fun. All right, so what happens if the number that you're multiplying by is actually a binomial, not just a number? So if we have x plus 2 times y and x plus 2 times 7, well, in that case, the x plus 2, if you'll notice, is the same. So it's in common. So what we can do is use we're going to use the distributive property backwards. All right. So let's take this x plus 2 out. So x plus 2, and then we took it times y, and we took it times 7. So the x plus 2 is in common with both this y and this 7. So what we can do is just pull it out and say, oh, well, I just multiplied the y times the x plus 2 and the 7 times x plus 2. So that's the same as taking this x plus 2 and putting these two together and making another binomial. So x plus 2 times x plus y is the same as multiplying the y, because remember, if we're going to check it, we'd have to take the y times this whole thing, and then the x times this, or with the x, the 7 times this whole thing. And so we'd get right back to where we started. We have to take y times x plus 2, and we'd have to take the 7 times x plus 2. And that gets us right back to where we started from. Okay? All right. So now, the reason we need to understand and see that is, of course, I'm going to make it difficult. Always, always. All right. So now, if you have a list of 4 terms, sometimes you can factor those by grouping them. So here's what we're going to do. We're going to group. I'm going to say, well, I don't know. There's all these. There's nothing in common. 6, 8, 3, and 4. 3 is prime, and it won't go into 8. So there's nothing in common with our constants. We've got x's. There's no x here, and we don't have y's and everything. So nothing is in common. So are you just done? No, you're not. Let's group the first two parts together and the second two terms together. And now let's look to see, well, these 2 terms have something in common, and these 2 terms have something in common. Let's pull out what's in common in those groups and see if it helps us. Let's see. And guess what? It's going to, because I did that on purpose. You know it. Okay, here we go. 6 and 8, those do have something in common. Those have a 2 in common, right? Because 2 times 3 is 6, and 2 times 4 is 8. So pull out the 2, that's in common. And it has an x squared in common, because there's x cubed here and x squared here, so there's 2 of them in there. There's just an extra one. So x squared is in common, and what we have left in this binomial now is 2 times 3 is the 6, and x squared times another x is x cubed, and then this is minus in between, and we didn't change the signs. 2 times 4 is 8, and x squared, oh, we already have the x squared, so we're finished. All right, now let's look and see. Plus, what do these 2 terms have in common? Well, the 3 and the 4, there's nothing in common. They don't have the x, oh, the y. They do have a y in common, right? So you can pull out the y. And now, 3x is what's left here, minus 4, because the y we pulled out. And now, does this look a little bit like this problem here? Because our 3x minus 4 matches the 3x minus 4 that we multiplied. So we multiplied this 3x minus 4 times two different things, but this is the same factor. Because this is the same factor, we can pull it out. So 3x minus 4 is the same in both. And we can look to see we multiplied it by this, and we multiplied it by this. So 2x squared plus y is what we multiplied it by. So when we factor this whole 6x cubed minus 8x squared plus 3xy minus 4y, if we factor it out to its smallest parts, we end up with 3x minus 4 times 2x squared plus y. Pretty cool, huh? Okay, so the trick is that you might need to go back and look at that again. Back it up and watch and see where I got all the parts and pieces. Once you get it, it's quick and easy and it's really fun. But you may need to back it up and look and see, well, where did this number come from and why? So the trick is, if these two match, if these binomials match, pull them out as one and then take the parts that they're multiplied by and make one binomial out of them. Okay, that's the trick. All right, last one. Because you know I can't leave you on anything remotely easy. We've got to have something crazy difficult to make your life difficult. All right, here's what we're going to do. At the end, I'm going to say, now factor completely. All right, you've got all the parts and pieces. You know how to do all of this. Now do all of it at once. Oh, you can do this. Okay, so first step is always, 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 and let's write that down. Write it down in your notes. The first step is to factor out the greatest common factor. All right, so step one, take out greatest common factor. Okay, so let's do that with this one. So we've got 12, 20, 24, and 40. Let's see. 12 is 4 times 3, 2 times 2, 20 is 5 times 4, 2 times 2, 24 is 6. I'm catching a, you know what? Let's just do this. 6 times 4 and 40 is 10 times 4. The 4s are in common all the way across the board and the other is extra. So let's just take 4 out. Okay, so 4 is in common. Now what about mn squared, mn? That both both of those have an m and an n. Oh, there's no m here. Oh, but there is an n. Ooh, there's n's in all of them. So let's take an n out, okay? There's only one n in this one, so we can only take one out. So let's take one n out of all of them. All right, once we do that, now we're going to take it out and see what's left. All right, so 4 times 3 was 12, and we took an n out of that one, but we still have the m, and we have one more n to make n squared. All right, and we didn't multiply by a negative on the outside, so all of our signs are going to be the same. All right, so minus 4 times 5 is 20, so we still have 5 in here. We took the n out, but we still have the m. Don't lose it. Signs are the same. 4 times what is 24? Well, 4 times 6 is 24. I have an n out, but I have an n squared there, so I still have one more n. The sign is the same. Bring down the sign. 4 times 10 is 40. And I took an n out, so there's no letters left. So far, that's what I've got. Okay, so that's step one. Step 2 is to look to see if you can group, all right? All right, so can you group them? You've got 4 terms here, so let's just try it. Let's try grouping this one and this one. Okay. Let's see. So if we do that, now don't lose the 4n on the outside. And then let's kind of keep a bracket around these. So now if we group these together, the 3 and the 5 don't have anything in common. The m's are in common though, so we can bring out an m. So m now times 3n minus 5. Do you see where I got those numbers? So 3 came from here. M times N goes there. The minus stays the same. I didn't take any numbers out, so 5 is still on the inside, but I took the M out already. So it's just 3N minus 5. Okay, now you got to be careful. There's a minus in front of here. Do we want to take out that minus? If we do, we got to make sure that we take it out here also. So minus 6 and 10, 2 times 3 is 6, and 2 times 5 is 10. So they have a 2 in common. So pull out a 2 of both. So minus, we're going to pull out a negative 2 to keep that first term positive. So negative 2, and there is no variable on this one. So we're going to have negative 2 times 3 is 6. 2 times 3 is 6. And the n, we didn't take that out, so we have to keep it in there. And because this is negative, this sign has to change. And 2 times 5 is 10. Okay, I promise we're almost done. Hang in there. You're doing good. All right, so now the last step is to look to see, oops, I didn't close my brackets. Got to keep them all neat and tidy, don't you know? All right, so the last thing is to look and see, oh, looky here. This 3n minus 5 matches this 3n minus 5. So because they match, you can pull them out. So be careful. Don't lose that 4n. That still stays, that kind of tags along to everything. This 3n minus 5, we're going to pull out. And when we pull that out, what's left is m minus 2. And now we're finished. Okay? So there's only a few of this type that have 2 steps. The first few problems are going to be pulling out using negatives and practicing, making sure that if you're pulling out a negative from a binomial or trinomial, that you change the signs on all of the terms in those parentheses. All right, so you're going to do some of those, and then you're going to factor by grouping, and then the last few are going to be factoring completely, where you'll have to factor out a monomial first, factor out a GCF, and then group them. You can so do this. All right, see you next time.